This chapter, configuring OSPF routing. This is going to teach us the basic configuration. I showed you yesterday when we were doing one small lab, I showed you that we can do OSPF configuration or enabling OSPF under the interface. I showed you by capturing some packets, putting debug command. Hope you remember that. So today, that's what this chapter is going to teach us. This is going to teach us how we can configure OSPF in different ways. Yeah. This is a process ID, a number. This number can be any number, and this number need not to be same on every router. The process ID is just to identify a process. I think it's funny because I repeated the same thing. Process ID that identifies OSPF process. What is special in that? We need to think like this. Why do we need to identify a process? When OSPF itself will have a unique ID. Why I need a process ID? Every protocol has got a unique ID, you know that? IP 88, IP 89. What is this? EIGRP, OSPF, identifications. Then why do I need a process ID when I have OSPF IP ID? So when OSPF has got a protocol identifier 89 and OSPF works on layer 3, then why there is need for another ID, process ID? But 89 can also identify the OSPF process. Then why I should say router OSPF 1 or router OSPF 2? It's because you can run more than one OSPF on a single router. On one router you may have more than one OSPF. If you want, you can have it. There are many reasons why we need it. Which you will come to know when we get into the deep dive of CCI syllabuses. So we can have more than one OSPF. To differentiate one OSPF from the other, we need a process ID. Next is the network command, which is optionally used now. Here in this presentation they have said this as an optional one, but nowadays you see this as the optional one. This has become somewhat widely used default method now. This is what I used in yesterday's class. To enable OSPF, I went to the interface and say IP OSPF process ID area ID. If the IP address on the interface is, let's say, 10.1.1.1/24, when I put this line of configuration, this network will be now advertised. OSPF will start running on this interface. This interface will be a member of area 0 or something, whatever the ID I prefer there, which can also be configured like this. The classical way is like this: network 10.1.1.0 and then wildcard mask 000.255 area 0. Both are same. This is under the router mode, this is under the interface mode. This is much easier. You don't need to write any wildcard mask. You may use any one of this or both on the same router. Both also you can use. Or any one of this you can use. It's your choice. The advantage of this is you don't need to write the wildcard mask. Whatever the mask that is already prescribed by you will be taken as the mask, subnet mask. Here this will use the wildcard mask that you mentioned, like 10.0 or 10.1.1.0. if you say 0.0.0.255 area 0, what does it mean? The first 3 octet, if it matches in any of the interface, that interface need to be a part of OSPF. So you can decide any one method and you can follow. You see here, this is 10.64. The mask is /32, but the mask here prescribed is only /8. Why? This is a wildcard mask, opposite of subnet mask. Is that okay? It is okay. What does this mean? This means that any interface that has got 10 in the first octet should run OSPF. 10 in the first octet should run OSPF. So this interface has got 10, so it will run OSPF. And here you see they have typed the entire IP address and they put mask completely. What does this mean? All the 4 octets should match on the interface. Only on that interface OSPF will be running as area 0. Wildcard mask is just to say how many bits need to match. Here we say all 32 bits need to match. Here we say just match first 8 bit. It's up to you. Depending on your choice, your wish, you can use. So this is also allowed. Like on one of the interface, you have done under interface level OSPF configuration under interface like IP OSPF 50 and area 1. So whatever the address that is there on the interface will be taken by the OSPF process. Whatever the mask that is specified here will be taken by OSPF, and this interface will be a member of area 1. Whereas the same router, you got also another interface F00, but we are not configuring anything under F00 other than IP address. We are not configuring any OSPF. For OSPF, we do the classical method. See the same process ID 50. Same process ID 50, but this is not under the interface. This is router mode, network 10.64.02, and we put complete mask /32 mask and area 0. What does this mean? This means that any interface that matches with this all 4 octet should be part of OSPF. Okay, you may use both, mixing like this method and this method, or you may use any one of this. It's up to you. Now, OSPF uses the router ID in order to prevent loop. Repeating again, OSPF uses router ID to prevent loop. Say for example, there is one router here, there is another router here, there is another router here. Let me name this router as router 1, router 2, router 3. If router 1 sends an update, router 3 has already learned the update. Remember in previous class I told about the the sequence number. Let's say the sequence number 50, for example, small number I'm putting. It usually 7-digit hexadecimal number. I'll show you that later. Now router 3 has received the sequence number 50 update directly from R1, but R2 do not know about this. R2 will just forward it via all other interfaces except from where it is receiving. It received on this interface, so router 2's responsibility is to forward it via the other interfaces, so it goes to router 3 now. And router 3, without any confusion, it ignores the packet, not because of the sequence number. First it compares the router ID. Earlier R1 only gave an update with sequence number 50. Now the same R1 sequence number 50 packet is coming. If some other 50 it would have received, but it's R1's 50. What is R1 here? Router ID. For you and me to understand, I use R1, R2, but OSPF don't use these names. OSPF uses ID. So there won't be a loop now. If R3 learns this, then there will be a loop. And if R3 gives this one to R2, it will give whatever comes from R1, will give to R2. If R2 takes it, then there will be a loop. And assume there is another router here. This gives here, this gives here, this gives here, and when a packet comes, this sends here, this sends here, they will stop looping. But actually the original destination is in R1. To avoid this loop, OSPF uses a unique identifier. It's unique because an IP address is picked up as a router ID. See, in an organization, only when someone does mistake, there are chances of two interfaces having same IP address. Otherwise, in an organization, every device will have a unique IP. Only when someone does mistake, there are chances of having more than one router having same IP address. You see, so we need to make sure we have not done that mistake, like configuring same IP address on more than one interface within an organization. It will conflict, no? IP addresses are to identify device. We don't ping with the MAC address, we ping with the IP address. So the IP address need to be unique within an organization. Now OSPF is designed to pick one of the IP address on the router as a router ID. Every router is going to pick an IP address. Every router is going to pick an IP address from the interface. Which means all routers should have a unique ID. because it's an IP address picked as a router ID. Is there any other way for a router ID? Yes, there is a way. You can also assign a 32-bit ID that need not to be there in the topology anywhere. See, in my topology, I don't have an address called e.e.e.e anywhere. I have not assigned this IP address to any of the router, any of the interface, any of the computer. Still, you can use this as the router ID. Can someone ping this address? No way, because it's not on any interface. But it can be a router ID because it's just a router ID, because it is just an ID. So router ID is like a name. You may assign a router ID manually, the ID which doesn't exist. If you do so, that will be given high preference. If you don't do that, the next preference is given to the highest IP address on the loopback interface. The highest IP address on the loopback interface is always preferred to be a router ID. What if the loopback interface doesn't exist? Then the highest IP address on the active physical interface. Highest IP address on the active physical interface. Okay, so as I told you already, configuring manually the router ID using this command always overrides the loopback interface preference as well as the physical interface preference. But there is a warning here. Cautious. What is that? Let's say when you configure OSPF, there was one loopback address, loopback interface with an address 1.1.1.1, and the physical interface address 100.1.1.1. This physical interface is F00. The highest IP address, will it take this IP address? No. Highest IP address among the loopback interface. I have only one loopback, so this is the only highest. So this will become the router ID. Physical interface address will not be a router ID. The loopback interface will be the router ID always. Only if there is no loopback interface, it is going to see the physical interface. If you have more than one physical interface, the highest IP address among the physical interface address will be used as router ID. But what is the cautious here? What's the warning that I want to give here? This is non-preemptive, meaning I'm trying to say what is that but non-preemptive. Router ID, but router ID is non-preemptive. What is that? When you enable OSPF, loopback interface was there. This is taken as the router ID. And you got another neighbor connected here. To that neighbor, it has already started speaking. That is the condition. It is already speaking to the neighbor. It speaks to router 2. Router 2, my dear router 2. My name is 1.1.1.1. Glad to meet you. How are you doing? Router 2 is saying, wow, that's nice. I'm fine. You speak English? What is your name again? 1.1.1.1. Okay. My neighbor is 1.1.1.1. Router 2 has learned a neighbor called 1.1.1.1. After this, if you now try to configure using the router ID command, it cannot override, will not override, meaning now I go to router OSPF and say from now on I want to use 11.11.11.11 as the router ID. This OSPF router will say, wait a minute, you are a owner, no? You are the owner of this router, so I respect you a lot. I take your configuration, but I cannot change my name immediately. I accept your new name that you are trying to give me, 11.11.11.11, but I cannot immediately change my name to 11.11.11 because I have already told everyone my name is 1.1.1.1.1. So I accept your configuration, but I cannot use it immediately. When will you use it? When OSPF process starts. When will the OSPF process starts? You can clear the OSPF and start it, or when the router reloads. You see, you can clear to start the OSPF process so that this new address will be taken as the router ID. See, if this command is used on OSPF process that are already active, so if already there is an active router ID, the new router ID used will be only after reload or manual process restart. So is router ID important? Yes, it is important. Why it is important? To prevent loop. OSPF will never work without a router ID. If you don't configure manually by using this command, router ID, if you don't use it, if you don't use this command, then OSPF is going to dynamically pick from the loopback interface. What if I have more than one loopback interface? It compares the IP address and the highest IP address of the loopback interface will be used. What if I don't have loopback interface nor router ID configured manually? Then it's going to use the active physical interface IP address. If more physical interface, then highest IP address from the physical interface. Do you have any question on OSPF router ID selection process?
So for sir, in a single area there can be only one router ID, means there one will be elected as a router ID, how it is?
Every router will have a unique router ID.
Okay.
Every router needs a name. Every router needs a name and it should be unique. If two people have same name in a class, it confuses a lot. Similarly, you cannot have more than one router with the same router ID within an area. It will conflict. You got it?
Got it.
Sir, if you run two OSPF in the same router, then there will be two router IDs. Right?
Very nice question. Joseph is eligible to be a CCIE. This question is a very nice, valid question. This thinking is good. You know, every OSPF needs a unique router ID. That is the best way to say. Instead of saying every router needs a router ID, every OSPF needs a unique router ID. So if you have two OSPF running on a router, there will be two different router IDs. See, repeating again, I told you if there is a loopback interface and a physical interface, loopback interface IP address is 1.1.1. Physical interface IP address is 110.1.1. So what this router will do, it will use the loopback interface IP address, correct? So when you configure router OSPF 1 or any number, first OSPF you are enabling, it will use this router ID. When you configure second OSPF, router OSPF 1000, this is the second OSPF you are configuring. This will not take, this will not. See how many will not I am saying. It won't take the same router ID which already picked by other OSPF. It will try to see another loopback interface not present. Then it is going to use this one as the router ID. You see? Because the routers run more than two OSPF, which means they need to differentiate between one OSPF from the other. If they have same router ID, then there is conflict. There is no point of running two OSPF. You need two OSPF, then you should have two separate router ID. That's a good question, Joseph.
So sir, it will be good if we manually configure the router IDs.
That's you, or wish. It's up to you. It's up to you. If you want manually configure, yes, you can do that. That will have a clear picture of what is speaking to you. With the router ID, you will know who is speaking to you. Which router, which OSPF is speaking to you. So the loopback interface that is used as the router ID, if you don't advertise it, it is okay. Still it will be a router ID. Still it will be a router ID. It will not be advertised, so no address is consumed, no space is consumed, so it saves the space. It won't be in the OSPF table. Only in the only as a router ID it will be there. It won't be there as a network in the routing table or OSPF table. It cannot be pinged because you are not running, because you are not advertising the loopback interface in OSPF. Again repeating, an address that you use as a router ID need not to be there on the interface. If it is there, that need not to be advertised in OSPF, not compulsory. So if you don't advertise, these are all the advantages. It won't be there in the OSPF table. It won't be consuming the space because it's not under OSPF advertisement list. It will not be it won't be pingable. It will be just the address. But if you advertise that same address that is used as a router ID, it can be pinged. It will use some space. It will be there in the routing OSPF table. If OSPF process is already running, the router must reload or the process must be removed and reconfigured before a new loopback that's already spoken. We have finished talking about this. To restart the OSPF process, this is the command clear IP OSPF process.
Sir, I have a doubt actually.
Yes, please.
Sir, for every OSPF we have to use different router ID, correct? Unique router ID.
Yes.
In the same router also, if I want to use Two OSPF. Two OSPF means two different process ID. Am I correct, sir?
Two different process ID, two different router ID, both separate.
Both should be separate. Okay. Only two different process ID and keeping same router
Not
ID
possible.
will not allow.
Not possible. It won't allow you. Anyway.
It will allow, but
No, it won't allow. It won't allow.
It will.
It won't allow. Another thing is, talking about more than two OSPF is not needed now. When we reach that level, CCI level, first we'll finish CCNP level. Then when we get into CCI level, we'll talk about that. But questions are answered. What you said is correct. You need a OSPF process ID and the router ID. Two separate. Now some verification commands, you see show IP OSPF is one verification command. It shows the router ID that is already picked up, the process ID that you configured, and it shows whether any of the interface is in area 0, any interface in area 1. This router appears to be an ABR because I see it's a member of area 0 as well as area 1. It's an ABR. So note down these commands, and I'll be giving you a lab assignment today which you need to do and show me tomorrow. These are the verification commands: show IP protocol, show IP protocol, show IP router OSPF, process ID if you have more than one OSPF, otherwise you don't need to type this process ID, show IP OSPF interface, and then the interface name will show you what area that OSPF interface belong to, what router ID it uses, how many adjacency it has made, all those info. Here show IP OSPF neighbor will show you those neighbors that are established. See, these are all sample output. Show IP route OSPF shows only the OSPF routes. When you see O, which means OSPF, IA means inter area, coming from other area, meaning this network is not from same area where this router A belong to. This is from different area. Show IP OSPF interface, it shows the router ID, it shows the network and the mask, it shows the DR, BDR. It also will show the neighbors. See, this is the neighbor. Yeah, this is a brief command. Show IP OSPF neighbor will show you there are two neighbors, full adjacency, detail will show you the same thing in much detailed way. Do and see these things. So today what we have seen is about the OSPF configuration, and I have also given you some show commands which is also listed here. If you have not noted, note it down now. I'm going to give you a lab exercise. You see, we'll be using this topology for various topics. So configure this ISP1 and ISP2. No, just attach this ISP1 and ISP2. Don't do any configuration on this. Likewise here also you don't do any configuration on this. No configuration on this interface. Don't do any configuration on this. Just simply configure. Connect. Just simply connect and keep. You need to focus on router 1 to router 7. Again, you see the word that I have mentioned here. Every router has got a router ID, and the router ID will be picked dynamically from the loopback interface address. For example, if it is R6, it will be 6.6.6.6/32. Yeah, so I'm giving you this topology. Put the IP address, put the area, configure area properly. Show me pinging from R1 to R7. That's your task.